In this video, I'm going to talk about how to find the area under the standard normal distribution. And before we jump into an example, I want to just talk about the standard normal distribution in general and what the areas look like under the curve. So we consider the entire data set as 100% of the data, and the decimal equivalent to 100% is an area of 1. So 100% is just the same as the number 1, or an area of 1. And so the area under the entire curve is 1 or 100%. So if the area under the whole curve is 100%, then each half is 50. So the upper half is 50%, which is considered an area of 0.5 or 0.50. So this upper half has an area of 0.5. And then the lower half is 50%, and that has an area of 0.5 as well. And so what we can do now is what we're going to do is look at some examples where we're asked to find the area between 0 and a certain z-score. And we're going to use the area under the normal curve table for this, or the z-score chart it's called. And note that I did do another video showing you how to use this chart, so you should check that out if you haven't seen it already. But in general, this chart only gives areas of the shape shown here that are between 0 and a z-score. If you would like to find the area, and I'll do a different video for this, where the area is offset from the center, so maybe it looks like this, then you're going to have to approach that a little differently. You do use the chart for these problems, but you approach it differently. So just keep that in mind. So let's look at example 1. We're going to start with the simpler problems first. So in this problem, we're going to use the z-score chart to find the area between the given z-score and z equals 0. We're going to draw a quick sketch. So I'm going to start by drawing a sketch. I find it's helpful to draw a sketch first. And I'll draw a sketch for both of these problems. And 0 goes in the middle. And then for A, the z value is 0.3. So I'm going to do that to the right of 0 since it's greater than 0. And I want to find the area between 0 and 0.3, so I'm going to shade it. Okay, and so now I'm going to look up 0.3 on the z-score chart. And so I'm looking for the z-score chart starts with z values of 0 in the upper left-hand corner, and then we have to just scroll down until we find z equals 0.3, which looks like it's right here, and it's got an area of 0.118. So I'm going to go back to my problem, and I'm just going to write in an area of 0.118. This is also the same if you converted this to a percent by moving the decimal 2 spots to the right. It's also the same as 11.8%. So 11.8% of values are between 0 and 0.3 standard deviations away from the mean. And so let's look at the second one. So a z-score of 2.92. This is a positive z-score, so that's also going to be to the right of 0. So I'm going to draw it further out than the last one since it's a bigger z-score. And I'm going to shade in the middle, just like I did the last problem. And then I'm going to look up on the chart a z of 2.92. So let's see. So I'm going to have to scroll a little bit further down than the last one. So I'm looking for z's in the 2s. And then, okay, so I think I found it. So it looks like z equals 2.92 is right here. And it's got an area of 0.498. So I'm going to go back to the problem and write in my area of 0.498. And this has a percent of 49.8%, which makes sense because it looks like almost the entire right half, which is 50%. So it's very close to that entire right-hand side. So now let's look at some examples where the z-scores are negative. So I'm going to start by drawing a sketch. These problems are very similar to the last two that I did. So I start by drawing the standard normal curve. So I want to put 0 in the middle. And then my z-score in A is negative 0.03. So that's really close to 0, but it's negative, so that's why I draw it to the left. The last time all my z-scores were positive, so I drew those to the right. And so I'm going to shade in between. And if you look at the z-score chart, all of the z-scores on the chart are positive. Keep in mind that the standard normal distribution is symmetric. So if I were to find the area starting at z0 going to a positive 0.03, these areas would be identical. And so that's what I'm going to do. So if you have a negative z-score, if you want to find the area between 0 and a negative z-score, just look up the positive z-score and it's going to be the exact same thing. And so I'm going to pull up my z-score chart and I'm going to look up 0.03, which is right here, and I get an area of 0.012. So this area here is 0.012. That's also equivalent to 1.2%. And then I'm going to do the same thing for B. So a z-score of negative 1.3 is going to be on the left. I draw it a little bit further away. 1.3, negative 1.3 is further than 0.03 from 0. So negative 1.3. I shade between. That's the area that I'm trying to find. And then I'm going to use the z-score chart to look up positive 1.3 because it'd be the same area between 0 and positive 1.3. So I'm going to look for z equals 1.3. And it looks like, let's see, it'd be 1.30. So sometimes on the chart there's an extra 0 added in, so don't worry about that. 1.3 is the same thing as 1.30, and it looks like that has an area of 0.403. So I come back to my picture and just label it with an area of 0.403. And then if I wanted to write a percent for that one, just move that decimal 2 places, and that's approximately 40.3% of values fall between 0 and negative 1.3 standard deviations. Now keep in mind 40%, that's almost 50%. So had I drawn my picture to scale, this section should have been bigger. It should have been more, almost half of that curve, but just, keep in mind these are just sketches. So when I'm drawing, I just make sure that the line, my z-score, is on the right side of 0, or the correct side, not necessarily right, it could be left or right, but I don't worry too much about drawing it to scale. I just do the best job I can, and usually that's good enough.